Solve the following system of equations. X squared plus y squared equals 36. Negative x plus y equals negative 6. So you should recognize these two types of equations. The first is a circle, the second is a line. And if we think about how a circle and a line could interact with one another, there could be potentially two intersection points. There may not be any intersection points, and there could possibly just be one intersection point, but probably there's going to be two. Now, to solve this system of equations, the best option to use available to us is substitution. So the idea in substitution is just pick one equation and solve it for one variable. So for instance, if I take the second equation, negative x plus y equals negative 6, I'm going to add x to both sides so that I get y by itself. So y equals x minus 6. Now I'm going to use that in the other equation. So the other equation, I have x squared plus y squared equals 36. So I'm going to take what I know for y and replace that into the other equation. So x squared plus x minus 6 quantity squared equals 36. Now, there's certainly different ways of using Gauss-Jordan and elimination for solving these types of systems, but in my opinion, the easiest thing to use is substitution. So to solve this, the x minus 6 squared is a quantity, so we'll multiply that binomial out. That will be x squared minus 12x plus 36. All right, now combining some terms here, I have x squared plus x squared, which will combine into 2x squared. The negative 12x doesn't have anything to combine with, but when I subtract 36 from both sides, notice that it will cancel out on both sides of the equation. So now that's just equal to 0. The easiest way to factor this is to pull out a common factor of 2x. So 2x times x minus 6 equals 0, so that x equals 0 and x equals 6. So these are the x locations of the two intersection points. So what's happening is my line is intersecting with the circle in two places. But I need to have the y solutions as well. And if you'll recall, we had this equation right here where y was solved by itself. So I can take that and figure out the y values associated with x equals 0 and x equals 6. So if x equals 0, then y is 0 minus 6, which is negative 6. So one solution is 0, negative 6. And if x equals 6, then y equals 6 minus 6, which equals 0, is what I meant to write there. So the other solution that I have is 6, 0.